Okay, now let's look at the first type of transformation. We said that there are 6 types of transformations. Let's look at the first type, which is a translation. So now a translation is displacement of a shape without changing its orientation. So this simply means that you move a shape from one position to another without changing its orientation. If we had a shape like this, right, we can move it to another position like that, right? We did not change its orientation. We didn't flip it one way or the other, but we simply moved it from one position to another. So if that's your shape and the image is there, then you can tell that that's a translation. If you ever see a shape and image that have the same appearance and same orientation, it is definitely a translation, right? Now, what happens with transformations is that a transformation, you are either asked to perform it, right? Remember, for your transformation, you have a shape and then a transformation that maps that shape onto an image, right? So I'm going to call the transformation T, right? So you have a shape, a transformation, and the image. So usually you are asked to either find the image or describe the transformation. So those are the two things you are usually asked to do. They can give you a shape and give you the transformation, and then you have to find the image, or they can give you the shape and the image. Now you have to describe the transformation that mapped that shape onto that image. So now, how do you describe a translation? If you so happen to see that, okay, here we have a translation, what do they require of you, right? Whenever you're describing a translation, you need to mention two things. Number one, you need to mention that it is a translation. So that's the first thing you need to do. You need to mention that this is a translation, right? The next thing you need to do is to mention the translation vector. The translation vector. Now, the translation vector, right, usually consists of two numbers, right? So, for example, I can have a translation vector t with 4, 3, right? So a translation vector will be a column vector with two numbers here, right? These two numbers describe the movement from the original shape to the image, right? How many steps in the x direction did the shape move? How many steps in the y direction did the shape move? Meaning how many steps did it move left or right? And then how many steps did it move up or down? So whenever you describe a translation, there are two things you need to remember. You need to mention that it is a translation, and then you need to also quote the translation vector for that translation. Okay, so now we have an illustration of a translation, right? As you can see, if this was the original shape and that is the image, we can see the shapes are the same size, same appearance, right? Same orientation, right? So same size, same appearance, same orientation. The only difference between these two shapes is the position. So whenever you have a shape and an image which differ only in position and nothing else, then that's definitely a translation. That's definitely a translation. So if I'm asked to describe the transformation that maps this first shape onto the image, I will simply state that it's a translation and then mention the translation vector, right? I'm going to look at the translation vector. Here's another illustration of a translation, right? You have the shape, if this was the shape, and that is the image. As you can see, the shape and the image have the same appearance, same size, only difference is their positioning. Okay, now let's look at an example. Triangle X has vertices at minus 1, 1, minus 3, 1, minus 1, 3. Draw the triangle X. So let's draw the triangle X. We'll look at the part B afterwards. Let's draw the triangle X. So minus 1, 1, those are the coordinates of the first point. Minus 1, 1. So that's the first vertex there. And then the second one was minus 3, 1. Minus 3 and 1. So minus 3 and 1. That's the second vertex there. And then minus 1 and 3. Okay. So minus 1 and 3. That's the third vertex there. So let me just use another color. Perhaps the green will do. Here's my triangle. What's the name of the triangle? The triangle is X. So I can name my triangle X there. So I've got my triangle X. That's my part A. Vertices are simply the corners of the shape. So this is just the coordinates of the corners of the shape. We've drawn that. Now, the second part is triangle X is mapped onto triangle P by a translation vector 5 minus 2. 5 minus 2. Draw triangle P. Now, what you need to do is you need to find the coordinates of the triangle P, right? Of the vertices of triangle P. The triangle X moves from its original position by this vector, right? So all you have to do, if you're going to find, right, the coordinates of the image, right? So if you want to find coordinates of the image, you just take coordinates of the original shape and then you add the translation vector t, right? So the coordinates of the original shape were minus 1, 1. I'm just going to write them as a column. Minus 1, 1. Write that as a column. And then we had minus 3, 1. Minus 3, 1. And then we had minus 1, 3. Minus 1, 3. So these are the coordinates of the original shape, right? The vertices of the original shape. To find the vertices of the image, we need to add the translation vector to all of them. As you can see, I've written them as columns so that they match the form of the translation vector. So our translation vector is 5 minus 2. So I add 5 minus 2 to all of these. So 5 minus 2, add there. 5 minus 2 there. 5 minus 2 there. So it means every point is being adjusted by 5 minus 2. So minus 1 plus 5, that's 4. 1 minus 2, that's minus 1. So that's the first. And then minus 3 plus 5, that's 2. 1 minus 2, that's minus 1. So 2 minus 1, that's the second. And then minus 1 plus 5, that's 4. And then 3 plus minus 2, that's 1. So what do I have? 4 minus 1. 2 minus 1. 4, 1. So let's make room for our shape, right? Well, you can actually fit without. So let's draw it. So 4 minus 1. 4 minus 1, that's our vertex there. Minus 2, 1. 2 minus 1. 2 minus 1, that's our second vertex there. 4, 1, 4 and 1, that's our third vertex there. So we can draw our shape there. So that's our resulting shape. That's our triangle P. So that's how you translate a shape. So if you are given a shape and you're given the translation vector and you're asked to find the image, you can find the coordinates of the image of the vertices, the coordinates of the vertices of the image by simply adding the translation vector to the vertices of the original shape, and then you get your result for the image there. Okay, so this is what we would get. We would have had minus 1, 1 there, minus 3, 1, minus 1, 3, and we're simply going to add our translation vector, right, which is, 4 minus 1, which is 5 minus 2. So 5 minus 2, 5 minus 2, and another 5 minus 2 there. Not the tidiest, 5 minus 2. And then we're going to get our coordinates for our image, right? 4 minus 1, 2 minus 1, 4, 1. So you just create some space for working like this, and then you can get your coordinates for your image. So this is what we simply did earlier on here. Just repeated it where there's more space for it to be clear. Okay, so we've got another example. Triangle A has the vertices 2 minus 1, 5 minus 1, and 3 minus 3. Draw triangle A, right? So let's do it. So 2 minus 1, 2 minus 1, our vertex is there. 5 minus 1, 5 minus 1, our vertex is there. 3 minus 3, oh sorry, so 3 minus 3, there we are. So we can draw our triangle by joining those points. And what's the name of our triangle? Our triangle is triangle A. Name our triangle A. Now, they said triangle A is mapped onto triangle B by a translation vector 4, 5. Draw triangle B, right? What do? You simply take the coordinates of the vertices here of A and add your translation vector, right? So 2 minus 1, 5 minus 1 are the coordinates of A. So 2 minus 1, 5 minus 1. Then the last one is what? 3 minus 3. 3 minus 3. To these points, you simply add your translation vector, right? What's your translation vector? 4, 5. 4, 5. 4, 5. 4, 5. 2 plus 4, that's 6, minus 1 plus 5, that's 4. 5 plus 4, that's 9, minus 1 plus 5, that's 4. 3 plus 4, that's 7, minus 3 plus 5, that's 2. So these are the vertices of your image. So 6, 4, we can now draw it. 6 and 4. 9 and 4. Oh, sorry. Wrong direction. 7 and 2. 7 and 2. So once we've done that, we can draw our image of our shape B. So really that's the process of translating a shape. If you are going to translate a shape, you are given the translation vector. You simply add the translation vector to the vertices of the original shape and you get the vertices for your image. So there's our shape and there's our image. Okay, now let's move to the next part now. This is now describing the transformation. Describe fully a single transformation that maps triangle R onto triangle S. Now, if you look at it here, we said that if the two shapes are exactly the same, in other words, they've got the same orientation, same size, it means a translation happened, right? But whenever you mention a translation, you must also mention the translation vector. But the first thing we can do is we can mention it's a translation. We can simply write the word translation. That's sufficient, right? So that's a mark for you in the exam. Just writing that word translation. You have identified that of the 6 transformations, this is a translation. Now, we have to be clever now. We're told that the transformation is going to map triangle R onto triangle S, right? Now, if you remember what we were doing earlier on, we were taking vertices from the original shape, adding the translation vector to get vertices on the image, right? Remember, this is the shape and this is the image. The image is the result, right? So when you take a point on the original shape and you add the translation vector, you should get what? the the point on the image. So if we rearrange this equation here, right, we'll get our t is equal to, if I take r that side, if this is an equation, if I take r that side, right, this is an equation, it becomes a minus s minus r, right? So whenever you mention or whenever you are describing a translation, you must at all times mention the translation vector. How do you get the translation vector? You just take a point on the image and take a corresponding point from the original shape and subtract the point on image minus the point on the original shape. So I can look at these two and pick any point, right? I can pick this one here. And the corresponding point is this one, because this one is going to move there, right? So on the image, this point is 6 minus 1. Those are the coordinates. 6 minus 1. So I'll write it as a column. 6 minus 1. And then on the original shape, this was 3 and 4. So 3 and 4. So I need to take the coordinates of the image and subtract the coordinates of the original shape for me to get the translation vector. So I take 6 minus 1, 6 minus 1, minus 3, 4. This is going to give me 3 minus 5. So that's my translation vector. So I'll mention that it's a translation, and then I'll also remove that, mention the translation vector. I'll say that translation vector is equal to 3 minus 5. So whenever you're describing a translation, make sure you also mention the translation vector. It's very important. How do you find translation vector? Just go to your shapes and the image. Pick any pair of corresponding points. I could have picked this one and that one, or I could have picked this one and that one, right? Just pick a pair of corresponding points. Take the final point on the image and take its coordinates and subtract the original point on the shape's coordinates, right? The answer that you get is the translation vector there. And in this case, our translation vector was 3 minus 5. So describe fully a single transformation that maps triangle R onto triangle S. All you have to write is a translation, and the translation vector is 3 minus 5. If you write exactly this, you will get your 2 marks. Usually translation questions are 2 marks. Okay, so here's another one, right? Describe fully a single transformation that maps triangle. Was this a triangle? This wasn't a triangle. So this was shape A, right, onto shape B. So this wasn't particularly a triangle, right? Just cross that out. So shape A onto shape B. Now, what do we know? Shape A and shape B are the exact same size, exact same appearance. Only difference is the positioning. So this is definitely a translation. We mentioned that this is a translation. The next thing we need to mention is the translation vector, because every time you mention a translation, you must have a translation vector. We need to calculate it. How do we calculate it? We pick a pair of corresponding points, right, between the shape and the image. So we can pick these ones, right? This point is going to move to that point, right? So what happens? It's A onto B, right? So I take the image. The coordinates here are 5 and 2, right? So this is 5, 2 of this point here. And then on the original shape, it was minus 3, minus 2. So minus 3, minus 2. And remember, to find your translation vector, you have to take the point on image minus point on original shape. So I'll say 5, 2 minus 3 minus 2. So 5, 2 minus a minus 3 minus 2. 5 minus a minus, that gives you a plus. 5 plus 3, 8. 2 minus a minus, that gives you a plus. 2 plus 2, 4. So our translation vector is 8, 4. So that's it. That is the description. A translation with a translation vector of 8, 4. That's the complete answer.